Hi folks, it's time to talk about greatest common divisors and least common multiples. So first let's talk about the greatest common divisor. Greatest common divisors we're going to use to simplify fractions, and we also use them to solve a lot of story problems. You'll see some in your homework. So the greatest common divisor, what is it? It's the greatest whole number that will divide both of two given numbers. So we write GCD, usually parentheses, A comma B. You can capitalize or use lowercase, and people do all kinds of things. So as long as it says GCD and parentheses A comma B, I don't care how you capitalize. Some people call this the greatest common factor, or GCF, and that's perfectly good too, right? Divisor and factor basically mean the same thing. So let's see some examples. I want to find the greatest common divisor of 12 and 18. So I want something that divides 12, divides 18, and is as big as possible. So although 3 divides 12 and 3 divides 18, it's not the GCD because there's a bigger common divisor, and that's 6. 6 is the biggest number that divides both. So the GCD of 12 and 18 is 6. The GCD of 6 and 30 is also going to be 6 because 6 divides 6, 6 divides 30, and there's no number bigger that will divide both of them. You'll see that the GCD of two numbers actually is one of the numbers if one of the numbers divides the other. So 6 divides 30, that's why 6 is going to be the GCD of 6 and 30. So there's three ways to find the GCD. The first one is to make a list of divisors, and we basically want to find the biggest number that's on both of the lists of divisors. So we just write out all the divisors of both numbers and look for the biggest number on both lists. So I want to find the GCD of 24 and 30. So I'm going to write out all the divisors or factors of 24. So I start at the bottom. I'll take 1 divides 24. So does 2 and 3 and 4, not 5. 6 divides 24, not 7, 8. So notice something right next to each other. I have 6 and 4. I should have noticed there that 6 times 4 is the 24. Once you find two numbers next to each other that multiply to give you the number, I know I'm going to start getting pairs. So the 4 matches with the 6. The 3 times what is 24? 8 will be the next pair. So after the 6 will be an 8. To the left of the 3, there's 2. 2 times what is 24? 12. That's what I'm going to put next. And what multiplies with 1 to give 24? 24 is going to be last. So those are my divisors of 24. Divisors of 30. I know 1 divides, 2 divides 30, 3 divides 30, not 4. 5 divides 30, 6. 5 times 6 is 30. So I now know the rest of the divisors are going to be in pairs. And I have 5 and 6 there in the middle. The next number is going to pair up with the 3 to multiply to 30. So I'm going to put a 10. The next number is going to multiply by what's to the left of 3? 2. 2 times what is 30? 15 is next on the list. And then to the left of the 2 is the 1. 1 times 30 is 30. So I now have both lists complete. And what's the biggest number that appears in both lists? It's 6 again. Seems to be my favorite number so far. That's my GCD. And here in this slide, I'm trying to point out again that factors or divisors do come in pairs. And once you find out in your list the two numbers beside each number, besides each other that make the number, then they'll kind of make a little nested list. So on the bottom, I'm talking about multiplying together to make 40. 5 times 8 in the black make 40. To the left of the 5 is 4. 4 times what is 40? 10. So the 10 goes on the other side of the 8. So I have the 5 times 8 in the middle in black. Around them 4 times 10. Around them, 2's on the left, so 20 goes to the right of 10, and 1 goes to the left, and 40 goes on the right. It just will help you pair them up. That way you won't miss any of the divisors. And missing divisors could give you a wrong GCD, so we want to make sure we don't do that. Use those factor trees that we've talked about in earlier lessons to help you find GCDs. So what you're going to do is take each of the numbers you're trying to find the GCD, factor them into primes using factor trees if you like, use exponents, and what you're going to do is look at each prime and take the smaller power of each prime and multiply. If you have a prime that's a factor of one of your two numbers and not the other, you're going to omit it. You could think of the one with a missing prime as having a 0 power of that, and 0 is going to be the smaller power. See an example. So I want to find the GCD of 72 and 60. So I factor 72. I know that's 8 times 9. 8 is 2 cubed, and 9 is 3 squared. So 72 as a product of primes is 2 cubed times 3 squared. 60. I'm going to factor that. It's 6 times 10. That's 2 times 3 times 2 times 5. That's 2 powers of 2 times 1 power of 3 times 5 to the first. So I look at each prime. I have 2 cubed and 2 squared. I am going to take the smaller power, so I'm going to use 2 squared. I have 3 squared and 3 to the first. So I'm going to use the smaller power, 3 to the first. I have 5 to the first in 60. I don't have a 5 in 72. That means I'm not going to use 5 at all. And so my GCD is going to be 2 to the 2 times 3 to the 1. And that's 4 times 3, which is 12. 12 is the GCD. If I've done this right, 12 should divide 72. And it does. It's 12 times 6. 60, 12 divides it. That's 12 times 5. And the 6 and the 5 we just got as the quotients don't have anything in common, right, as far as factors go. So I know I have the GCD. So I have 4 problems for you. Factor these ones using prime factorizations. The first 2 I made, you have to factor them yourself using a factor tree. The second 2 I factored for you. Don't multiply them all together. That will make the problem so much more horrible. But just look at the powers of each prime and see if you can find the GCD. And so your answer could have things like, I'll have 2 to this power times 3 to this power times 5 to this power, that kind of product of primes form. Give them a try. Stop your tape. And here I have done the examples for you. So you can stop and check your work and join me in a minute.